Alrighty, here's number 7, and it looks like we're supposed to solve these things graphically. Provide a graph to justify your solution. So I don't know if he means to do this by hand or do it with like graphically on a calculator. So we'll do it by hand. So basically what you want to do is graph this left side like it's its own equation. Graph the right side. Let's do that one in red like it's its own equation. And we're just going to use equal signs for them. And then we'll just compare the outputs. And if you look, we're going to be looking for outputs where this graph's y values are greater than this graph's y values. His y values, though, are always just 6. So we're just going to be trying to find out where these y values out of this function, what x is causes to be bigger than 6. All right. So to do this, I'm just going to graph this guy, and we'll do it right here on our paper. So the first thing is let's prep it for graphing. So I always want my x term first. It's a negative x, negative 2x. So I put it first, and it's still a negative 2x plus 2. And then I'm going to factor out this negative 2 in front of it, giving me an x minus 1. And there's a little property. Now, I don't know if he's taught you this or not, but I assume if your teacher's doing it this way, he will. So if you have the absolute value of a times b, you can take that and separate it as the absolute value of a times the absolute value of b. Okay. And so that's what we have here. This is negative 2. That's like my a times x minus 1. The whole x minus 1 is like my b. And so I can separate this into this product like that. And the reason I want to do that is because this absolute value of negative 2 then can be evaluated. So this is the cleaned up form of this absolute value equation. Okay. At least this is how I would do it. Because once I get it like this, if you remember how absolute value functions go, this is just the parent absolute. All right. It goes over 1, up 1, over 2, up 2. On the right hand side, it's just going up 1, over 1, up 1, over 1. And on the left hand side, when you put in a negative 1, it also gives you a positive 1 out because you're going to absolute value it. So here's what the regular absolute value looks like. So if you remember in translations and transformations of functions, one of the things we learned is that when you have x minus 1 inside your function, this causes it to shift left and right. And in this case, it shifts left by 1. So this graph right down here is going to go left 1 unit. But it's also got a 2 in front of it, so it's going to be a vertical stretch. Now, all that means is that when I plug in a 1, instead of outcoming a 1, it's going to stretch up to a 2. Okay. It just gets multiplied by this 2 in front. And when I step out to 2, I usually get a 2 out, but now it's going to be multiplied by 2. So this point would be stretched up to a 4. Okay. So this 2 out here causes this graph to be stretched vertically 3, 4, like this. It just makes it taller and skinnier, essentially. Okay. So here I go. And we're going to have to graph it relatively accurately because we're trying to solve this thing accurately. So I'm going to draw just a nice little XY axis here. I'm going to take this graph right here and I'm going to shift it left by, I'm sorry, I said left by 1. That's a negative 1 in there. This is going to shift it right by 1. Right 1. If you plug in a 1 there, 1 minus 1 is 0. So when I get to 1, I get a 0 out of this thing. So this thing's going to be shifted right there to positive 1. And then I'm going to graph a few points here. I need to get up to 6. 4, 5, 6 to do it. Because at y equals 6, that's where this equation kicks in. All right. And now I'm going to start graphing this to x minus 1, but I just graph it from here. And so I go over 1, up 1, but it gets stretched up to this multiplied by 2. So I get this point. Usually when I step to the right by another 1, I would just go up to 2, but now I'm going to stretch up to a 4. So at 2, or when I step to the right one more, I got to stretch up here. at 2. So now I'm up here at 4. And then I stretch up to a 6 when I get to 3. 2, 3, 6, way up there. Okay, so you have to adjust where you draw it. And then uh, absolute value functions have nice symmetry. So step to the left by 1, I'd have a point there. Step to the left by 1, I'd have a point there. Stretch to the left by 1, I'd have a point way up here at 6. So there's my absolute value function. Here's the equation y equals 6. It's just a horizontal line right there. And so now I can see, when is the absolute value part? When is it greater than 6? So right here at this point, this is at x is -2 here. I'm up here at 6. Um, and as soon as I go to the left of that 6, so like -3 over here, my line of my absolute value is higher. It's greater than 6 now. So these are y values that are higher than that y is 6. And then over here, these are y values that are higher than this 6. But I'm looking for the x values that cause that to occur. So if I just measure where this x at, that's x is 3. So when x is greater than 3, when I'm on this side, 4 and 5, then my absolute value gives me these y values. Okay, so I need to have x's that are bigger than 3 in my answer. And then over here, this occurs, my graph isn't very good there, but this occurs at x is -2. So I need x's on this side of the -2. So I want x's that are less than the -2. So to sum it up, there's your graph. And my answer is, and he uses set notation sometimes. So it'd be like, set of all x's where x is less than a -2 or x is greater than a 3. And you can, test these things. And one way to test them to know if you're correct is to try the hot spots. The hot spots are right where it transitions from being, hey, I'm greater than to I'm less than. So right here at -2, I would want to plug that x value in. When I plug that x value in, it should give me exactly 6. So plug in a -2, it'd look like this. And that's the absolute value of 2 plus 4. And that gives me absolute value of 6. So right at that x is -2, it comes out to exactly 6. And as soon as I go left of that 6, or that -2 rather, like -3, all of a sudden the number we get over here will be bigger than 6. So that's how that works. Let's see here. Was that it? Oh, that's it.